a different type of angle. Now, Friday we talked about central angles. Central angles, the vertex is at the center of the circle, and a central angle is equivalent to its intercepted arc. So this angle here is equivalent to the intercepted arc here. This is awesome. I'm watching everyone take notes because you can use your notes on the quiz Friday. This second figure here gives us an inscribed angle. Now, an inscribed angle is one in which the vertex lies on the circle and it's formed by two chords. So this inscribed angle here is equivalent to half the intercepted arc. So here's my intercepted arc, 2x, so this would be half of that, x. So anytime we have an inscribed angle, the measure of an inscribed angle is equal to 1/2 the intercepted arc. Okay, you try 1, 2, and 3. What do you guys think about number 1?
35.
35. So it's going to... It's 1/2 the intercepted arc, so it's 35 degrees. Number 2.
200.
200. We're going to double it going backwards. And number 3.
100.
100, because the intercepted arc would have to be 100 degrees, and therefore the central angle is also 100 degrees. Nice job. Okay, so on this one we have some that look a little different.
I feel like they just find ways sometimes to just like try to combine all the units together.
They do.
Like, yeah.
Yeah. Well, math is like that. Things just go together. If we look at this angle right here, do you see it intercepts this arc? Do you see that this angle also intercepts that same arc?
So they're both, and they're opposite interior.
Okay, so they are both 80 degrees.
Oh, that was not opposite interior.
That was supposed to be 80. So what is y?
Oh, 160.
160. Okay, let's take a look at this one now. Let's see if we can figure out what this angle right here is. Angle X. do you see that this is intercepting a semicircle? So you're absolutely correct. Someone right over here said it. Was it TJ? It was Lou. Nice job, Lou. This has to be 90 degrees. So what do we know about an angle that intercepts a semicircle? It's always going to be
90.
a right angle, yeah. And if that right angle actually is part of a triangle, then the hypotenuse of the triangle is a diameter of the circle, isn't it? And we have a right triangle. Therefore, we can go back to our Pythagorean theorem, can't we? Now, pretend a little bit that this one touches perfect. Okay, so this triangle here intercepts a semicircle. So what kind of angle is right here?
90.
A 90 degree, a right angle, right there. So this is an a squared plus b squared equals c squared. Now it tells us that the radius of this circle is 10.
So 20.
So this would be the 10 here and the 10 there. So the hypotenuse would be 20. Now find the missing leg.
3, 4, 12.
12. Nice.
Okay, I know exactly what his brain did. He goes, ooh, that's a 3, 4, 5. It's a multiple. And it's times 4. And 3 times 4 is 12. That's what his brain did. It just spit out everything out loud, so y'all all got to hear his brain. It's kind of cool. Okay, so he's right. It is a multiple of the 3, 4, 5. He noticed that all these were being multiplied by 4. So instead of doing a squared plus b squared equals c squared, he goes, oh, that's the one I'm missing, 12. Now, if you had done x squared plus 16 squared equals 20 squared, you would have still gotten 12. Any questions? Okay, so an inscribed angle that subtends, that's kind of the same thing as intercepts a semicircle, if and only if the angle is a right angle. IFF, if and only if.
Wait, what is subtend?
Like intercepts. That it intercepts the circle. I don't know why I can't just follow that. I'm focusing very hard. Still went off. It's not much better. Beautiful, Adrian. That's right. Any questions? Okay, I think this is our last topic of the day. Oh yeah, because the next slide is your homework. So let's take a look at this. The measure of A, angle A, plus the measure of angle C equals what? All right, so angle A, right here, right? And angle A intercepts that whole arc. Does everybody see it? Okay, now, do you notice that angle A is part of a quadrilateral that's inscribed in a circle? So this is going to work anytime we have a quadrilateral inscribed in a circle. Now let's take a look at angle C right here. Do you see that it intercepts that arc? Together, isn't that the whole circle? And aren't inscribed angles half the intercepted arc? So the whole circle would be how many degrees? 360. But because it's an inscribed angle, it would be half of that, or 180. So it works for A and C. Does it work for B and D? Take a look at it. Let me erase my colors. Let's start over. Okay, so let's try highlight orange. So B intercepts from here to here. And then let's do D. It intercepts from here to here. Did the whole circle get colored again? Yes. So opposite angles are always going to be, what's that special word for when they add up to 180? Supplementary. So if a quadrilateral is inscribed in a circle, the opposite angles are supplementary. Now, some of you are very visual, and you see all of this stuff right off the bat. Some of you might benefit from taking some highlighters and highlighting your figures and looking at different things that way. If you need to highlight on your test, go for it. I'm good with that. Now, unfortunately, the SAT will only allow you to use pencil. They won't even let you use colored pencil. So you'd have to just kind of shade things with your pencil, I guess. But on my test, you can certainly use a highlighter. All right, so your homework out of your textbook, these problems, go ahead and give it a shot. See if you can get it done before school's out.